Good afternoon, and welcome back to this session post lunch. First session post lunch. That's why probably you have a little less segment. Probably they're still. We'll wait for 5 minutes. Iqbal? Okay. Good afternoon, everyone, and welcome back to this first parallel session post lunch. In this particular session will be conducted by. We are very happy to invite Dr. Suprana Kachaini. She is an interdisciplinary socio-ecological researcher with a specialization in water resources governance, brings together natural and social sciences aspects to bridge the knowledge and governance divide. Her focal areas are the water, food, energy nexus for advancing resource security, sustainable and inclusive development, and mainstreaming climate action in the water sector. Before joining CEEW, she was working with Tata Institute of Social Sciences in Hyderabad, where she built the capacity of MS students on socio-ecological research, approaches to conservation and development, and understanding climate change. She has also developed a research project on higher education on climate change and sustainable development as part of the Climate U network. I request Professor Suprana Kachaini to share the session.
Thank you so much for inviting me to chair this session. And we will open the session with a talk by Dr. Parvinder Maini. Let me start by introducing her to the audience. So, Dr. Parvinder Maini is currently serving as Scientific Secretary at the Office of Principal Scientific Advisor to the Government of India, where she is involved in the Prime Minister's Science, Technology and Innovation Advisory Council, Empowered Technology Group, the Science and Technology Cluster, and other major initiatives steered by the office. Dr. Maini has a doctorate in meteorology and oceanography and has vast experience spanning over 32 years in diverse fields. With a master's in mathematics, Dr. Maini began her career at the National Center for Medium Range Weather Forecasting in 1990s. She has also played a pivotal role in implementing and executing the atmospheric science program of Ministry of Environmental Sciences and Earth Sciences, and also the program on extramural research. As program head international collaboration, Dr. Mani provided leadership in strategic management of MOES international portfolio of both bilateral and multilateral collaboration. Dr. Mani headed the Data and Strategy Unit of MOES and was responsible for monitoring and evaluation of various schemes at MOES to ensure data driven, tangible outcomes. We invite Dr. Parvinder Mani to deliver a talk on nurturing sustainability via effective policies for water security and climate change in the contemporary world. Please, Dr. Mani, join us.
Distinguished speakers, colleagues from industry, academia, students, and of course also international delegates, a very good afternoon. A typhoon in China. One eat the water that we drink. About 2 billion people worldwide don't have access to safe drinking water. And of course, the IPCC report has clearly brought out that the world's population is experiencing severe water scarcity for at least one part of the year. So these numbers, of course, are expected to increase due to climate change and population growth. And only point of water on Earth is available as fresh water. And climate change is dangerously affecting that supply. It is therefore high time we all take a note of this and take corrective measures to secure water, as this is a natural resource that we need to actually preserve. And it is actually impacting the changing our lives. Now, water has become, of course, a climate connector. Increased frequency and low-date precipitation, melting of glaciers, alteration in seasons timings, floods, droughts, receding groundwater storage, soil health, freshwater ecosystem, all these are related to water. So this is something that we need to actually preserve. Now, let us see how the climate has affected the rainfall and temperature over the past 30 years. Now, this is the global rainfall pattern that I'm showing you. The left-hand panel is a rainfall and the right-hand is a temperature. The left-hand side shows the rainfall derived from the Climate Research Unit's gridded data set at 1 degree. Now, if you look at the rainfall pattern, the upper panel, of course, is showing the 1961 to 1990 precipitation pattern. And the middle pattern is showing the 91 to 20 pattern, the last 30 years. And the lower panel, of course, is showing the difference between the middle and the upper panel. Now, if you carefully see, the rainfall south of equator has actually decreased in the last 30 years, whereas in the north of equator, it is showing change in precipitation patterns. And some places are wetter and some places are, of course, drier. Similarly, if you see the temperature plot on the right-hand side, which clearly shows rising temperature, and this, of course, coordinates well with what WMO has already said, that there's a likelihood that the annual average near surface global temperature between 23 to 27 is going to exceed 1.5 degrees Celsius. Now, let us look at the same picture of the Indian region. Now, the upper panel is rainfall, which is based on India Meteorological Department's gridded rainfall dataset at 0.25 degrees resolution. And the lower panel is mean temperature using both CRU and IMD data at 0.5 degrees resolution. And the rainfall plot, of course, is again showing a changing pattern, and you can see a lot of patches in the third panel, which is a difference between the middle and the left-hand side panel. And similarly, if you look at the temperature plot, it's clearly showing rising temperatures all over India. So there is definitely a rising trend of temperature. Now, while there is high confidence that climate change is ongoing and set to continue, there is certainly around, key elements of water cycle, how they are going to actually evolve, that is still not very certain. So uncertainty is particularly high when we discuss future precipitation patterns due to differences between climate model results. As the climate models currently lack the spatial and temporal details often required for adaptation studies or also the planning. So we need to have effective policies in place. So I'm really happy that IIT Madras has organized one special session on government and policy. Now, United Nations defines water security as having sustainable access to enough water of adequate quality to support people's well-being, livelihood, and health while safeguarding the ecosystem. Now, if you see a look at the picture, which is derived from WHO, you will see that there is a growth of nearly, the proportion of the global population with access to safely managed drinking water has increased from 62% to nearly 74% in 2020. And of course, the projection indicate that this growth will persist. It will persist till 2050. That is what the projections state. So this is primarily attributed to factors such as expansion of the population, advancement in socio-economic conditions, and responsibilities in consumption habits. Now, the Sustainable Development Goal on water aspires to ensure availability and sustainable management of water and sanitation for all. The water resource planning, along with increasing urbanization, development, and population growth, need to be factored in while deciding climate action. And this is being followed by many of the countries. So while water management strategies are already in place for certain sectors, but the larger question is whether these will be sufficient to cope with the projected rate and magnitude of change to water resources under climate change. So now let us see the small efforts. My whole presentation will cover small efforts that are being made by communities, by states, by across the globe, by countries across the globe, and also a small units by some government efforts during this direction. And especially all this thing which is linked with water. Now, according to the latest assessment report by the Intergovernment Panel on Climate Change, in the agricultural sector, the overall irrigation water demand is set to rise by 2080. So, the efficient use of water through appropriate incentives for on-farm investments aiming to improve soil and water management is definitely required. So, drip irrigation, soil moisture sensors, satellite evapotranspiration measurements are some of the ways that we can achieve this, and we can achieve efficiency and productivity. In order to encourage farmers in the water-stressed areas to grow less water-intensive crops, the National Water Mission, Ministry of Jal Shakti, is launched an awareness generation campaign called the Sahi Fasal. So under this, lot of workshops can be held in many states in India, where the farmers have been educated to stop growing water-intensive crops and encourage them to use micro-irrigation techniques. Now in Cambodia, Nepal, and the Philippines, water users associations have helped secure investments for development agencies, such as the International Fund for Agriculture Development, on projects involving irrigation canals, drainage structure, and water conservation systems. Public-private partnerships have been set up for infrastructure projects to encourage water distribution, treatment, and transmission. Now, in Latin America and Caribbean, there are irrigation boards or committees called water cabinets, which is actually an advisory council which actually advises on what is the course of action to be taken as a water policy for the national and international research units. Now, agriculture adaptation, like targeted water delivery to the crops via drip irrigation, which is very popular in Israel, we all know about it. This has been developed and commercialized, and it also gained popularity as it has demonstrated that cultivation of rice requires 70% less water than the traditional paddy system, That is 5,000 liters against only 1,500 liters with drip irrigation. To minimize the impact of climate change and reduce its carbon footprint, countries have made commitments to achieve carbon neutrality. Even India is also committed, especially towards in the energy transition sector. Now, for this, industrial decarbonization is one of the prime targets. Industry take about 22% of the water against agriculture, which is consuming around 40%. So major industrial applications of water use includes power plants, manufacturing plants, ore and oil refineries, and hydroelectric dams, and so on. Now, with the climate change, there are alterations in the water flows, and it can also affect the energy generation and consequently have an impact on the technological processes. So, for instance, for the manufacturing of semiconductor chips, ultra pure water is used, and this ultra pure water is used multiple times, multiple rinses for a single chip. Around 2,200 gallons of ultra pure water is needed for a single chip. Now, to produce 1 gallon of ultra pure water, approximately 1.4 to 1.6 gallons of municipal water is required. Sorry, I skipped the slide. Which means that rinsing process may necessitate as much as 3,520 gallons of tap water. So this is the kind of water that we require for the semiconductor chip. Now, when we talk about energy transition, hydrogen has emerged as the most viable alternative for energy carriers. And green hydrogen, of course, is gaining wider acceptance as an agent for industrial decarbonization. Now, of course, hydrogen, as we all know, is being produced through electrolysis of water. The International Agency report has estimated that the current hydrogen supply consumes around 1.5 billion cubic meters of fresh water, which is 5% less than the total consumed by the energy sector. Now, to meet the net zero emissions, rapid growth in hydrogen production double this to about 3 billion cubic meters by 2030 and 13.2 billion cubic meters by 2050. Now, according to the EYSCD fund report, even if India needs to meet its target of 5 million metric tons of green hydrogen by 2030, that is the commitment that India has made, 50 billions of liters of demineralized water will be required. But this is just 0.33% of the current global fresh water. So that way, if you see the other renewable sources, that is solar, wind energy, that of course covers 25% of the renewable that will be required for this one, other than the water. So if you see, the production of electrolytic hydrogen is renewable rich, but water-stressed regions require careful assessment. And in these places, the use of desalination plants, of course, would help in depletion of fresh water resources. Now, industrial sectors such as water credit systems, analogous to carbon credits, can be thought of. We all know about the UN Green water credits that supports upstream farmers to invest in improved green water management. This could be redesigned to suit any of our countries' management of water resources. Now, this is the next slide on community health and medicine. Now, World Health Organization has been keen on health risks associated with water. Climate change causes heavy rainfall, leading to overflowing drains, and sewerage management becomes a problem. AMR issues become a problem. This leads to waterborne diseases like cholera, typhoid, and so on. And of course, even diarrhea. So, even the sewage water management, I said, is compromised, leading to a lot of waterborne disease outbreaks. So, the discharge of antibiotics and other pharmaceuticals into water bodies can also contribute negatively to the aquatic environment. Now, addressing the intersection of health and water security requires multidisciplinary approaches like implementing robust wastewater treatment systems and promoting clean sanitation, responsible use of antimicrobials in healthcare, agriculture, and aquaculture, and surveillance systems to monitor microbial contamination in water systems and tracking the spread of resistance genes and pathogens. Now, the Office of PSA is actually spearheading a program called the One Health, which is looking as an integrated approach to the human, animal, and environmental surveillance. And early warning through this can help us in knowing what are the pathogens that are prevalent, and we can take corrective measures. Now, Office of PAC has also established S&T clusters. This is a flagship initiative of the Office of Principal Scientific Advisor, where the aim is to make the academia, R&D institutes, local bodies, industries to work together to tackle local problems or regional problems through S&T interventions. Presently, of course, we have 6 such S&T clusters. Now, under the Pune cluster, the Pune Wastewater Surveillance Project was launched in 2021 with an aim to track and identify new COVID-19 variants. Various stakeholders, including the Pune Municipal Corporation, has actually helped in getting a lot of samples to make a dashboard. The dashboard, of course, is displayed here, offers insightful visualization derived from the comprehensive data set fetched from sewage water treatment plants located in Pune area. Dataset encompasses crucial information such as STP locations, sample counts, and all expertly portrayed through a combination of geographical maps and line graphs. This definitely helped in the COVID-19 wave prediction, and that way Pune could take some corrective measures and also enabled water security. Now, if you see this map, which is showing the water withdrawal as a percentage of total available water, if we see the 2025 image on the right-hand side, it is clearly seen that 1% of water withdrawal in the northern part of, percentage of water withdrawal in the northern part of African continent, North America, India, and other adjoining nations is more than 40% up from 1995 figures. This is, of course, very, very alarming. Now, in order to safeguard water amid the backdrop of climate change, it is crucial to establish pathways that provide clean drinking water. According to the shared socio-economic pathways, the global volume of domestic water withdrawal is projected to reach a figure of 700 to 1500 cubic kilometers per year by 2050, up from the 2010 figures, indicating an increase of 50 to 25 to 50%. So at the national level, of course, so we have to take a lot of corrective measures. So let us look what is being done in India. So at the national level, the Indian government has designed the Jal Jeevan Mission, Har Ghar Jal program. This is a program which is highlighted even by WHO for its efficiency in averting the death of approximately 4 lakh people from diarrhea. So the objective is to ensure a consistent and sustainable supply of safe drinking water to every rural household through tap connections by 2024. And this will, of course, the immediate impact is accessibility to piped water. And it also minimizes the gender-oriented burden of water collection, which is generally done by the women folk. And it gives them time for more education and employment. The Jal Shakti Abhiyan 1 of 2019 was launched in 2019 in 256 water states districts of India by the Indian Ministry of Jal Shakti with the basic aim to promote water conservation and undertake water resource management through 5 targeted interventions, which I mentioned here. And in 2021, the scope of Jal Shakti Abhiyan 1 was expanded, and Jal Shakti Abhiyan 2 was launched with the theme, Catch the Rain, Where It Falls, When It Falls. So this covered the pre-monsoon and the monsoon period. And of course, rainwater harvesting, water conservation, and geotagging and making inventory of all water bodies, all was undertaken under this campaign. And all states have been requested to set up Jal Shakti Kendras or rain centers in all districts to create awareness and give technical guidance. Globally, we all have heard about this, the European Union Water Initiative, which has the UNECE and OECD as the strategic and implementation partners in Eastern Europe, the Caucasus, and Central Asia. Together, they implement the national policy dialogues with national authorities with an aim to achieve the water related sustainable development goals. And another initiative is the Water Europe, which is a multi stakeholder platform. This was also initiated by EC in 2004 as an European technology platform. And under this, the Water Oriented Living Labs was created to encourage the co-creation, validation, and implementation of technologies to create a water smart society. The other program, the International Water Stewardship Program, was launched in the sub-Saharan African region and to encourage collaboration among different stakeholders. This was, of course, started by Germany and UK, basically to coordinate action plans that makes all water users equally responsible to share the resources and work together. In this, 30 companies involving 29 partnerships and working under a PPP model have cooperated under this program. And so far, 8,60,000 people have benefited in several ways from the activities of this program. Now, the other major initiative that India has taken is the Amrut 2.0. Under this, this is actually an extension of Amrut 1.0 that was launched in 2015, and it actually focuses on making cities self-reliant and water secure. It seeks to promote circular water economy by focusing on sewage reuse, water body rejuvenation, and water conservation through city water balance plans, and has a total outlay of 2,770 billion. Now, master plan of Delhi for 2041, which is actually having a focus on fostering a sustainable, livable, and vibrant Delhi, is also focused on rejuvenating the natural assets by reducing pollution, greening of built environments, and diverse portfolios of natural and planned open spaces. Now, under the rejuvenation and restoration in the global arena, the Aral Sea Basin program is actually very, very famous. Under this, this was actually basically aimed to rejuvenate and restore the obsolete aquatic ecosystems. It is a long-term action program which was started in 1992, and its fourth phase which commenced in 2018. Due to decades of excessive water diversion for agriculture and industry, the sea had been steadily shrinking and was on the brink of ecological disaster. So as a first step, dams have been built to separate the northern and southern part, as you can see in the slide. This helped to stabilize water levels in the northern part and prevent further desiccation in the southern part. In addition, water has been diverted from the Sir Darya and Amu Darya rivers, which feed into the Aral Sea, to replenish the northern part of the sea. And this, of course, has helped in increasing the water levels and restore the ecosystems. Of course, this program is a collaborative effort of World Bank, UNDP, and EU, and has approximately benefited 4 million people. Now, all of us have heard about the National River Linking Project, which has been under discussion since 1980. This is, of course, basically focuses on water, transferring of water from water surplus basins to water deficient basins. But of course, this has its own challenges because this requires states to actually agree to these plan, whatever is proposed, whether they're ready to share the water, the rivers that are flowing from their regions. Under this, the National Water Development Agency has already identified 30 links. In that, 16 are under Peninsular component and 14 are under the Himalayan component. And feasibility reports and DPRs are already under preparation. Now, if you actually see the population which is actually not having access to lot of facilities are the ones which actually suffer a lot. Now, this is, of course, now before I come to that, this is one slide which I've actually skipped on rejuvenation and restoration. This is called the Mission Kakatiya. This is actually in the state government of Telangana, which is the youngest state of India. It targets to restore all tanks and water bodies by undertaking dredging, removal of encroachments, and in turn enriching the groundwater table. This project, of course, has helped to design the geospatial and geotagging database that monitors 45,000 tanks and is gradually increasing. So, this success story has become the talk of the day, and many international bodies are also talking about it. Then, of course, the Namami Ganga program, which is implemented by the National Ganga Council since 2011. This, of course, mission aims at rehabilitating and boosting the existing sewage treatment plants through curbing pollution at exit points of the riverfront in order to check the inflow of sewage, to maintain the continuity of the water flow without changing the natural seasons variation, to restore and maintain the surface flow and groundwater, to regenerate and maintain the natural vegetation and aquatic biodiversity. And of course, as I was talking about the tribals who do not get the basic needs, the basic needs of these tribals are also not addressed, and water security is a major problem for them. So we have highlighted the interventions that is being carried out on water security measures in the cities. So it's equally important that we also highlight the measures that are being taken for the tribal and last mile communities, uh, especially linked with water conservation. However, there is a challenge because catering to their usage and customizing programs for their needs or their traditions, ethnic practices, and remote habitats is actually definitely a big problem. And it's a big problem for planners, for climate scholars, and so on. So, WAT3 is a exclusive initiative for the tribals of central India. It focuses on strengthening a self-reliant tribal society with timely accessibility to quality and sufficient quantity of water, leading to an assured livelihood, alleviating poverty, and improving the quality of life. Now, the Himalayan region, the Hindu Kush Himalayas, which are known as the water tower of Asia, with 10 major rivers flowing through it. Here also there is a decline by 60% of low discharge springs. So locals have actually done some kind of innovation to ensure that the water is there for them when it is required. So they have built ice stupas, if you see, an artificial glacier made by piping mountain water and river streams. It benefits the local community. And these are natural ice reservoirs. It stores winter ice melt and water for dry month. This is how it is assured. Now, this is, of course, as I said, the picture shows the image of Puskal Lake, which is very much in the Chennai region. This was, of course, a rain man-made reservoir of the 19th century and serves as the primary water source for the city of Chennai. It has dried up gradually, if you can see the image, and therefore is a cause of concern. However, Chennai Metropolitan Development Authority has recently announced to rejuvenate the water bodies in the city. So thus we saw that in India and elsewhere in the world, lot of efforts are being made to secure the freshwater resources. With rising population and the alarming rate by which climate is changing, we need to also simultaneously make efforts to use the saline resources on Earth. We are aware that over 70% of the global water resources, how much time is it? Time is up? Oh God, give me 5 minutes more. So over 70% of the global water resources are saline. So we need to actually see how we can use it for potable purposes. So this is, of course, the world's largest operational plant. It's located in Abu Dhabi with a capacity of 9,09,000 cubic meters per day. And it's, of course, based on reverse osmosis. And, of course, impacts and gives supply to nearly 3,50,000 households. Now, this is, of course, the LTT plant, which is very much an operation since, demonstrated in 2005 and operation since 2018. It is developed by National Institute of Ocean Technology, which is basically, as it says, it works on the principle of temperature gradient between two water bodies. And it's actually in operation, as I said, in 5 desalination plants and gives about 1 lakh liters of potable water every day. And a future, which I was just discussing with my colleague, is emission-free water power supply to these plants. And These are other two pictures showing the India's first and largest seawater in Tamil Nadu since 2010, and the other one is in Gujarat since 2014. Important thing which is required for promoting sustainable land use practices and efficient stormwater infrastructure, innovative technologies. Now, the Spawn City, this is one example that I would like to say. This is an initiative in China. It aims to transform urban areas to sponges, absorbs and retains rainwater, and the national target is 80% reduction of urban runoff. Now, the Ministry of Power also, through its tariff policy of 2016 in India, has mandated, this is an aspect of water circularity, is mandated use of treated sewage water for cooling purposes, reduce freshwater consumption, promote the reuse of wastewater, and adopt zero liquid discharge technologies. I have 3-4 more slides. And of course, in all this thing, we need to bring in analytics. So a lot of work is going on using analytics such as AI ML for data management, AI models for channel networks, and so on. And one example that I would like to mention, which many of you people be knowing in the UK, which is assisted by artificial intelligence to predict and detect pipe bursts and leaks. And of course, on the right-hand side is talking about the clues model. And of course, this is a picture which is showing the efforts being made by Central Groundwater Board for artificially recharging the projects. And of course, in all this thing, international collaboration plays a very, very important role. So in India and Netherlands have actually signed some MOU for specific purpose, that is for water management. Similarly, even the Horizon 2020 was a very, very important and powerful platform where a lot of projects had been signed between India and the European Union on water projects. And in that, Pani Water is one of the very important projects which is actually focusing on quality of drinking water, wastewater management, and so on. Now, this is the last slide. The key takeaways from all that I have just told is that climate change and water scarcity is a reality, and we have to adapt to this change by finding workable solutions for water security. Efficient planning and legislations through hydro diplomacy, both at the state, national, international levels in the following. First is, of course, urban water conservation. Second is groundwater conservation management. Third is sustainable water use and governance. Fourth is wastewater management, water circularity, desalination technologies, and last is using advanced SNT tools. Now, in conclusion, Sarve Bharvattu Sukhina, which means happiness to all. So, lifestyle for environment. This is the logo which is being, this is the, of course, the sound of or the voice of Government of India, which is encouraging adoption of sustainable lifestyles in India to fulfill the SDG, especially the SDG 6 on clean water and sanitation and climate action. So this actually is a clarion call for us to take unified action for universal welfare and harmony, for mitigating harsh consequences of climate change on our planet, expedite the adoption of nature-friendly initiatives, invest in social and human capital, and endorse the metamorphosis from citizen as spectators to citizen as actors. Thank you.
Thank you so much, Dr. Mani. It was a pleasure to listen to your thoughts and also about the scientific advancements. We would have liked to have some questions, but in the interest of time, we would like to invite the audience to engage with Dr. Mani bilaterally and also discuss further on this interesting theme. Next, we would like to invite our presenter, Greta Sunderman, who will be presenting on organizational models for municipal implementation of resource-oriented circular sanitation using urine diverting dry toilets in Germany as public space. Greta, please join us. So just wanted to share, the presenters will get 12 minutes followed by a few minutes for Q&A.